Okay, we're going to start chapter 5, which is polynomials, and we're going to do factoring with them. So in introduction to factoring, first step is you find the greatest common factor, or the GCF, of monomials. We're going to factor polynomials when the terms have a common factor, factoring out the greatest common factor, factor certain expressions with four terms using factoring by grouping. To factor a polynomial is to find an equivalent expression that is a product. An equivalent expression of this type is called a factorization of a polynomial. The numbers 20 and 30 have several factors in common, among them 2 and 5. The greatest of these common factors is called the greatest common factor, or GCF. One way to find the GCF is by making a list of factors of each number. So when you make the factors of 20, you get 1 times 20, 2 times 10, 4 times 5. And so you keep going on. And in 30, you get 1 times 30, 2 times 15, 3 times 10, 5 times 6. The common numbers are 1, 2, 5, and 10. They each appear in the factors of 20 and 30. And the largest one is 20. So another way to find the GCF is to find the prime factorization of each number, then draw lines between the common factors. Okay, we're going to try the prime factorization and find the GCF between 20 and 75. So when we break 20 down to its prime factorizations, we get 2 times 2 times 5. And then on 75, when we break it down, we get 3 times 5 times 5. And the only thing that's a link is the 5. So the GCF is 5. Now we're going to find the GCF of 420 and 924 using the prime factorization. Now I'm going to do these for you, but if you need help in learning how to do these, remind me. So we have 420 equals 2 times 2 times 3 times 5 times 7. And then on the 924, we get 2 times 2 times 3 times 7 times 11. And so now we're just going to go through and see what are all the same. So we're going to draw lines. We have one pair of 2's, another pair of 2's, a pair of 3's, and a pair of 7's. So the GCF is going to equal 2 times 2 times 3 times 7. When you multiply all that out, you get 84. So to factor a polynomial is to express it as a product. A factor of a polynomial, P, is a polynomial that can be used to express P as a product. A factorization of a polynomial is an expression that names that polynomial as a product. So we're going to find the GCF of all of these. And then we're going to break them down by prime factorization. I will break them down for you, and then we're going to look at them. So for 30, x cubed, we get 2 times 3 times 5 times x times x times x. If I can get my pen to work. And then for negative 48, x to the 4th, we get negative 1 times 2 times 2 times 2 times 2, 1, 2, 3, 4, times 3 times 1, 2, 3, 4 x's. For 54, x to the 5th, we get 2 times 3 times 3 times 3 times 5 x's. And then for 12x squared, we get 2 times 2 times 3 times x times a. Now we're just going to go through and find out everything that is the commons. Okay, we're going to draw connectors to them. So we have that has to be in all of them. So we have 2 and a 2. I have a 3 and a 3 and a 3. And then I have 1, 2. I have one set of x's in each one and one more set of x's in each one. Okay? So when that's all said and done, we look at this and we're going to go through and we're going to find what the answer is. So we're going to say 2 times 3 times x times x. So our final answer is 6x squared is the GCF. Okay. To find the GCF of two or more monomials, find the prime factorization of the coefficients, including -1, as a factor if any coefficient is negative. And we did that in the other example. Determine any common prime factors of the coefficients. For each one that occurs, include it as a factor of the GCF. If none occurs, use 1 as a factor. Examine each of the variables as factors. If any appear as a factor of all the monomials, include it as a factor using the smallest exponent of the variable. If none occurs, in all the monomials, use 1 as a factor. And then the GCF is the product, to where you multiply them, of the results of 2 and 3. So when factoring when terms have a common factor. To factor a polynomial with 2 or more terms of the form AB plus AC, we use the distributive law with the sides of the equation switched. So we'd have AB plus AC equals A times BC. So let's think about it. First we're going to multiply and we're going to do distributive property. That means you have to multiply everything through. So when you do, you wind up with 4x cubed plus 12x squared minus 16x. Now on the other side it says to factor. Basically we're going to look through and see what the common factor in all of them are, and then we're just going to go back and see if we can figure it out. It's just like we multiplied everything times 4x, so it looks just like the other one. So now when we back out, we're going backwards. You come back to the original equation that we had when we multiplied. So those are the two factors that made up that trinomial, 4 cubed plus 12x squared minus 16x. So now we're going to factor this. What's the GCF of 9a minus 21? Now sometimes you should be able to look at what can go in both of those. So I'm going to assume that a 3 can go in both of those because 9 can't go into 21. So let's say if we divide 9a by 3, we're left with 3a, and then 21 divided by 3 gives us 7. If you were to distribute that back out and multiply, you're going to get the same thing. Again, we're going to factor. So if you can't figure out what the GCF, you can look and do the prime factorization. In this case, I know that the exponent to the variable is going to be an x3. So that tells me right there I can take out an x3 because there's an x in each one of them. And then what would go into 28 and 34 evenly? I'm going to say 4. So 28x to the 6th divided by 4x cubed is going to give us 7x to the 3rd. And then 32x cubed divided by 4x cubed is going to give us 8. And so if you multiply those back together, they'll come up to the same thing, or back to their original binomial. Alright, this trinomial, the GCF, We have to look to see what would go into 12, 21, and 24 evenly. And I'm going to say it's a 3. And then we just use the exponent or the variable, and we use the lowest exponent, the smallest exponent. So if we say 3x cubed, so that leaves us 4x squared minus 7x plus 8. Do y'all agree? So 3x cubed times 4x squared minus 7x plus 8. So now when we're doing this one, what do you notice? It has two different variables in there, doesn't it? It has an A and a B. You still have to factor those. So what would go into 9 and 18 evenly? 9. And what's the variable with the lowest exponents? We have an A squared and we have a B cubed. So we're going to take out, sorry about the little extra arrow there. So we're going to take out a 9A squared B cubed, and we're going to 9A cubed B to the 4th is going to leave us A, B, and then 18 divided by 9 is going to leave us a 2, and then the A squared and the B cubed go away, and that's our final answer. Now, anytime you have a negative that starts out, you want to try to pull a negative out, and that's going to change your sign, so you have to be very careful in that. So the GCF between all of these would be a negative 4, and it looks like there's an x in each one. So now we're left with y minus 2w plus 3. And again, if you multiply all that back out, it comes back to the same thing. Now, factoring by grouping, sometimes algebraic expressions contain a common factor with 2 or more terms. For example, if we were to factor x squared times x plus 2 plus 3 times x plus 2, remember, if you look, these are common in both of those. So it's a common binomial, so we can write that down one time. It'd be like if we took that out of both of them. And then what's left, we can put in a different set of parentheses, which is x squared plus 3. And if you foil that back, you would come back to that, you'd come back to something a little bit different. So the prime factorization is x plus 2 times x squared plus 3. If a polynomial can be split into groups of terms and the groups share a common factor, then the original polynomial can be factored. This method is known as factoring by grouping. It can be tried on any polynomial with 4 or more terms. So that's what we're going to look at. So our first problem that we're going to factor by grouping, what you do is you go in and you just drop in a set of parentheses, and we're going to factor out these two. Their GCF is going to be a 3x squared, so that's going to leave an x plus 3. And then on the other side, they don't have anything in common, but you can factor out a 1, leaving an x plus 3. Now, these binomials in the set of parentheses need to be identical. That's your trick. So we write them down one time, x plus 3, and then these right here, the x squared, or the 3x squared, and the plus 1, they go in the other set of parentheses. And that is your final answer. You have factored the factoring by grouping. So this 1 is always very important. And a lot of times people forget. That's why they say 1 is the loneliest number. It's because people forget about it. Maybe one day I'll be able to write neater on this iPad like I can on a board. Okay, so in the next one we're going to factor out by grouping. So when you rewrite this one, because there is a negative sign right here, it's just easier to do this. Plus, you leave that negative attached to that number because they go together. You don't want to take it out yet because it changes everything if you do. So now we're going to look through here and see that's an x to see what they have in common. So I get a 3x, so I'm left with 3x cubed plus 2. And then if this ever starts out with a negative, odds are you're going to be factoring out a negative. So I'm going to factor out a 9, and that leaves me a 3x squared plus 2. So I'm going to look here, are these the same? And they are. So I write them down one time. And then I write the other two that we found, the two common factors that we found, and they make up the other set of parentheses, and we are finished. So tips for factoring: before doing any kind of factoring, first try to factor out the GCF. This is most important, and I'll forget sometimes to ask you, because usually I already know the answers, but always ask and see if there's a GCF. And always check the result by factoring by multiplying.